Hey guys, my name is Tensor. Welcome back to the Dart Tetris tutorial video. This video will be part 2 of the Tetris tutorial, and we'll be finishing off the application by adding all the logic and stuff to make it work. In the last piece, we built up all of our model code and our blocks and tiles, and we made classes for all of the 7 different pieces that exist inside of the game. Now we want to go ahead and create a file that ties all of this together to make it run like an actual video game. For this, let's create a new file inside of the source folder. We'll call it game.dart. And of course, it'll be a part of the Tetris library. Inside of it, we'll create a game class, and this will hold all of the state for the actual game. We want to add some properties to this class. So we're going to need a canvas element type, which will be our board. Then we'll need an element type, which will be our game score. And the element type is just an HTML piece that we can manipulate so that we can put the score in there. Whereas the canvas element is literally just a piece of HTML canvas that we can manipulate. Then if you think about how Tetris works, you have a block that's dropping down the screen, and that's the block that you're controlling. So we need a field called our current block, which is that block as it's falling down the field. Also, we're going to need some fields for the width of the board, the height of the board, and then the cell size of the board. Remember, all of our pieces are made out of points, x and y coordinates that is, and we can then expand them to be 30 by 30 pixels with our cell size. And then the width and the height of the board will be based on our width and our height values. A normal Tetris board is 10 blocks in width and then 20 blocks in height. So we just take the width and the height and then we multiply them by the cell size. So our game board will be 300 pixels by 600 pixels. And if for whatever reason we want to make it larger, we can just expand it by changing the cell size number, which will also scale up the piece size. Now to finish off the fields for this game, we're going to need 4 more fields. We'll create an integer called lines cleared. This will be the score for our game. We also need the canvas rendering context 2D object, which will be how we interact with our canvas element. And then we need 2 main state objects to actually model the state of our board. So first we have this 2-dimensional list of integers, which will be our board state. And the idea is that we'll have a grid which will be 10 by 20, and this grid will be filled with zeros. Then as a piece is dropped down in the grid, that piece will exist in a space in this list as ones. And then all we have to do is find all of the ones inside of our board state and then render them to the screen with our canvas. Now the row state is just a one-dimensional list because it's just tracking how many blocks are in each of the rows. So it'll be 20 in length because our height is 20. And if we have 10 blocks in the row, then that means that we want to delete that row because it means that the user has completely filled up that row with blocks. So for instance, if you look at the piece configuration here, when I drop this piece, we'll have 10 here and 10 here, and then they'll get removed like that. Now we can go ahead and initialize some of these values inside of our game constructor. So first let's initialize that we want the lines cleared value to be 0. Then we can initialize the game score HTML element. And let's make it a div, and we'll give it an ID of score. And notice that I'm using the cascade operator here. Now we can set up the row state. We just use the list filled named constructor, and then we pass in the length, which will be our height, which is 20. And then we want to fill it with zeros, so we just pass in 0. Now for the board state, we can just use the basic list constructor, pass in the width, and then we'll map over the width. And we'll pass in an anonymous function that fills each of the rows with a list of height, where we only have zeros inside of it. So we'll have 10 different lists, each one with a length of 20 filled with zeros. Now notice I also have to call toList after we call this map method on the list constructor. And that's because the map method will return a iterator object rather than a list. Now that we have the constructor finished, we can go ahead and create a method which will allow us to generate random pieces. Let's call this method getRandomPiece, and we're going to use a random number generator for this. And because we have 7 pieces that we want to generate, we just call nextInt7, which will give us a number between 0 and 6. And then we can run a switch statement on this integer, and then based on the switch statement, we'll return a new block. So if we get a 0, we'll return the I block. If we get a 1, we'll return the O block. 2, we return the J block, and so on and so forth. Now notice I do have this simple return statement at the end, which just returns a block. That's only because I've got the type annotation up here. The code down here will never run, and we know this because the random number generator will always give us a number between 0 and 6. Now let's create a method that will go and check all of our rows and see if they have 10 blocks inside of them, and then clear those rows. We'll call it clear rows, of course. For this function, we're going to need to iterate through our row state, and we're going to need the actual index, so we have to use a for loop. Let's grab the row that we're currently looking at by passing the index into our row state and binding it to a variable. Then if that row variable equals our width, which is 10, we want to go ahead and remove it from our state and from our canvas. First, we can remove it visually from our board. So we can use what's called an image data object. We use our context to get this image data, and we want to get the image data for our board that is from 0 and 0 on X and Y, all the way up to the cell size times the width, and then the cell size times the index. If we look at our board like this, say I had a line down here that had 10 pieces in it, we would want to get everything from here all the way to the top of our board so that we can then move it downwards. And that's what we're doing with this getImageData function. Then we're using putImageData to move the actual data down 1 by passing in the image data here, passing in the change in X, which will be 0 because it's not going to move horizontally, and then passing in our change in Y, which will be our cell size. So we're just going to move it down by 1 cell size. Remember, with HTML canvas, as we're moving downwards, we're adding values to this Y value. We need to change the state to reflect these changes, and we can do this by using 2 embedded for loops. One of them will loop from the current index value all the way down to 0. And then the other one will loop from 0 all the way up to the width value. In the inner for loop, we'll take our board state and we'll take the X and Y values and put them in here. And then we'll set it equal to the board state X and then Y minus 1. So essentially we're just moving all of the numbers in our board state down by Y minus 1. We also want to repeat the same process for our row state. So we're going to move it down by Y minus 1. And then what we can do is take the 0 index of our row state, set it equal to 0, and then also take the board state, iterate through each of our columns, and set the 0th index of each of the columns equal to 0. Then of course, because we're going to be keeping score of how many lines have been cleared, we need to increment that value. To fully understand what's going on here, let's take a look at what the state of our board state and our row state would look like. So here's what our row state would look like when we first start the game. So it's just filled with zeros. It's important to keep in mind that the 0th index, which is over here, is the top of our board, and then the 19th index, which is over here, is the bottom of our board. Now say this is our game state at some point in the game. We've got 10 at the bottom, then we've got 4, 7, 2, and then 1. We want to get rid of the 10, right? So we're iterating through our row state here, and we're just moving all of the values over by 1 index. So 4 gets moved over to 19, 7 gets moved over to 18, 2 gets moved over to 17, and so on and so forth. And this line here really just accounts for what happens if we have a full line at the top of our list. Say we had a 10 here, because this only goes down to 1, because it has to be greater than 0, then this iteration never actually goes through this number. So the only way to get rid of it is just by changing it manually like this. So this 10 would then just become 0. The board state may seem a little bit more difficult, but it really isn't. Here I have a simplified version of our board state where this is just 4x4 rather than 10x20. Each of the interior lists is a column, and then rows are quite literally just the indexes. So this would be the bottom row, here, 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 and here. And then this would be the top row, here, 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 and here. Say for instance we have an I piece at the bottom with a T piece on top. This is what the board state would look like. So we'd have a 1 here, a 1 here, a 1 here, and a 1 here. That would be the I piece. And then the T piece would be this, these two, and this. Now because the I piece fills our board, we want to get rid of it. We just iterate through each of our columns by changing the X. And then we're just taking the Y value and moving it over like we did with our row state. So first we start with the 0th index, and we're just moving this over to here, this over to here. And so it would then look like this, where it's just completely zeros. For here, we have to move this one over here, and then this 0 over here. So then it would look like this. We're going to do the same over here, so then it would look like this. And then finally we do the same here and here. Of course, again, we can't account for the very top line. These values here, 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 and here. So we need to manually add them in with this statement here, where we're just iterating through each of the columns and replacing the 0th index with a 0 manually. Now let's create a method which will allow us to figure out whether or not we can move a piece in a certain way. So this is essentially a method that will decide whether or not a block has collided with another block, or whether or not the block has collided with the side of the board. We want to iterate through all of the tiles in the current block, which is the block that's currently dropping down the screen. Then as we're iterating through this, we need to check to see if the tile's X value is greater than or equal to width, or less than 0, or the tile's Y value is greater than or equal to height, or the tile Y is less than 0, or the board state where the tile is at its X and Y value is equal to 1. This being when it collides with another block value. If it does meet any of these conditionals, then we'll return false, otherwise we'll return true. Now let's create a method which will allow us to handle the movement of the piece. We'll call this piece moving, and it will return a boolean and take in a string s. First we'll create a field in here called pieces moving, and we'll set it equal to true. Now we want to go ahead and render the animation of the tile as it's moving. And so what we're going to do is first create a fill style to fill in the tile with gray, because the actual board itself will be gray. And this way, when the tile moves down the screen, we actually will draw the tile, then delete it, then draw it in a new position, then delete it, then draw it in a new position and delete it, and keep going like that. So we iterate through our current block, iterate through the tiles, we use for each, and then we call fill rect on our context to fill the actual tile, and we pass in the tile's X and Y. We multiply both of these by the cell size, and then the width and the height are the cell size as well. Now let's deal with whether or not the user is rotating our current block. So if the user hits the up key on the keyboard, it will send in a string that says rotate, and we can just call current block rotate right. Otherwise, we want the current block to move in the direction that's being sent into this function. We can now use our valid move function to change the pieces moving field that we created. So we take valid move, calculate it, and then we set the boolean value into our pieces moving, and we take whatever this is and we negate it. So if we get a true, then we'll have false, and if we get a false, then we'll have true. And this is how we'll know whether or not the move is valid. The reaction to an invalid move will be to move the piece in the opposite direction. If we're rotating the piece when the move is invalid, then we want to rotate the piece to the left rather than rotating it to the right. If the piece is moving to the left and it's invalid, then we need it to move right. If it's moving to the right and it's invalid, then we need it to move left. And we'll do the same with up and down. When we drop a piece to the bottom of the screen, it won't go below the screen because it will be pushed upwards. And then if a piece runs into another piece, say from the right side, then it can't collide with that piece because it will be pushed in the opposite direction. Now we can go ahead and actually render the piece onto the screen. So we need to change the context fill style into our current block's color. And remember, the color is based on the block type. Then we'll iterate through the current block's tiles again, and we'll render each one out using context fill rect. Finally, we want to return our piece's moving field. Let's put all this together now to create an update game method. This update game method will take in a timer, and this timer will determine when our screen refreshes. So by default, we'll put in a timer of 500 milliseconds, which means that the block will move downwards once every 500 milliseconds and the canvas will refresh. But if we wanted to make the game harder, we could then increase this timer value. First, we want to set up our game score. We want to set the inner HTML to be a p value with a string that says score and then has the lines clear value inside of it, and then we just have lines after it. Then we want to run an if check, and we want to see if the piece is not moving down. In other words, if the user is interacting with the piece or if the piece has collided with the bottom of the screen, then it's not moving down. And if it's not moving down, then we'll grab our current block, iterate through all of the tiles, and we'll grab the board state. We'll take the tiles X and the tile Y value, we'll set it equal to 1, so that each of our tiles will be represented with a 1 inside of our board state, and then we'll increment our row state based on our tile's Y value, so we can keep track of where the tile is inside of our rows. We then want to call to our clear rows method. And then after we've called to clear rows, we want to then get a new random piece by calling to our getRandomPiece method and set it into our current block. And then again, we want to check to see if the piece is not moving down, meaning we've basically crashed the game. And if we've crashed the game, then we want to call timer cancel, which will stop the game entirely. There are some final things that we need to set up here. So we need to set up a Initialize canvas function, which will initialize our HTML canvas. We'll grab our board field and we'll create an HTML canvas element by calling element.html, passing in canvas string. Then we need to set up the width and the height, such as width times cell size and height times cell size. And then we want to set up our context by calling board context2d to get the context2d API, and then we want to fill our board with gray, so we'll just call context fill rectangle from 0 and 0 along the entire board's width and height. We need to be able to capture keyboard events, so we'll grab document on key down, add a listener to the document, and this will have a callback function which passes back an event. We can check to see whether or not the timer is active, meaning the game is still running. And then we have a bunch of if statements that check to see what key code we're calling on the event. The left arrow is key code 37, so we call piece moving left. Then the up arrow is key code 38, so we call piece moving rotate. Then the right arrow on the keyboard is key code 39, so then we call piece moving right. The down arrow is key code 40, so we call piece moving down. And then to make it so that we can drop a piece all the way down the screen when we hit the space bar, we can check to see if the user has hit the space bar, and then we can execute a while loop, which will just loop while the piece can move down. Now let's finish up here by creating a method called start. And in our start method, we'll call our Initialize canvas method to set up the actual canvas on our HTML. Then we'll grab the entry point in our HTML document. And if we look at our index.html, you can see here we have a div with an ID of output. So we can just use our query selector to grab that div. We want to wrap our board inside of the div and then our game score below it. So we can just call entry point nodes add and then pass in board and then pass in game score. We then need to set up our timer so that our game will actually start. So we call timer.periodic, pass in our duration of 500 milliseconds, and then pass in the update game method. And then finally, we want to grab a random piece to start off our game, and then call handle keyboard with the timer inside of it so that we can handle any keyboard events. And that's it for our Tetris library. So now let's go into our main.dart file and import our Tetris library by calling import package Tetris, tetris.dart. And then in our main function, we can just call game.start. And that will then start our game. If you don't have webdev already running, you can go ahead into your command line now and run webdev serve to build your application and serve it on the development server. And then you can open up your localhost 8080 in your browser and you'll have your game running. Now notice that the game screen is automatically in the center. It's like that for me because I didn't change any of the CSS from the generated Dart project, and it automatically centers the div for us. Of course, you could improve this game if you wanted to by adding some CSS, adding features like a button to restart the game, adding features that allow you to pause the game, adding lines that allow you to define the pieces a little bit better along the grid, adding things like a ghost bar so that you can see where the piece will land and stuff like that, adding difficulties and other things like that. Alright guys, well I hope you enjoyed this tutorial. If you did, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the box below. And if you dislike this video, then by all means downvote it as much as you like. Have a good night.